Hello, my name is Teodora Ioana Dăncilescu. I'm studying computer science in the University of Craiova, and I'm going to present the paper titled More Data and Better Keywords Imply Better Educational Transfer Classification, developed together with Marian Cristian Mihescu from University of Craiova and from Universitatea Politehnică de Valencia with Stella Heras, Javier Palanca, and Vicente Huitul. This represents the main title of this paperwork. I will continue with the introduction part. Let's start with the motivation of research. In the last years, we can notice a persisting growth in the quantity of online learning objects and the massive online learning courses. This results in a problem for students as they have hundreds of thousands of online documentation. Therefore, topic modeling has become a trending topic for the e-learning research community. As a response to this trend, Universitatea Politehnică de Valencia in Spain launched a video lecture sharing website called Polymedia and massive online learning platform called UPV, which is powered by the very known edX platform. Searching through these videos is not very efficient because it is fairly clear that the basic retrieval solution overlooks any semantics. Presenting the aim of this research, we can state that this paper focuses on the improvement of this search engine by improving a previous work referred in the bottom of the slide, where previous Wikipedia articles were used as ground truth. This work aims to improve the previous semi-supervised method by questioning which one of the two factors in the previous work have a significant impact on the accuracy matrix of the final obtained data model, whether it's the size of the ground truth dataset Wikipedia articles, or the quality of the keywords used in the semi-supervised labeling. For presenting the proposed approach, we can talk about improving the data analysis pipeline in terms of accuracy of classification on the videos currently available in the database. As in the initial approach, the training on Wikipedia article uses the SVM classification algorithm, which uses the radial basis function kernel from the sklearn library. The validation approach uses the same two steps. The first step, train on 70% of Wikipedia articles and cross-validate with 15%. The second step, train on labeled transcripts and validate on remaining unseen 15 of Wikipedia articles percent. Another starting point was to observe where improvement could have been brought. From a focused analysis on the result of previous work, we could notice that humanities and arts were mislabeled as engineering due to some reasons. Some of them are the fact that humanities and art reach more various subjects that are not so domain-specific. Another reason would be that mathematics videos would prove the demonstration and analysis as they contain a large number of words that are not mathematics domain-specific. And many videos about the economy and economic environments tend to be categorized as engineering, as many explanations heavily use mathematics and calculus. An important thing to mention here is that biology and sciences domain did not encounter no confusions. That is a really good thing. Hence, after analyzing the previous results and approaches, we came up to proceeding to two main steps. The first step, training on more Wikipedia articles and determining better keywords, as these two aspects represented the key point in the overall results. When speaking about training on more Wikipedia articles, we may say that, intuitively, more data should help to improve accuracy, but in practice this may not happen. One issue that currently occurs in machine learning systems is whether or not the size of the dataset is too small for the classification problem. Proper debugging of the data analysis pipeline should clearly point out if current accuracy results may be improved by using a larger dataset or other leverages should be taken into consideration. As a first approach, we try to detect a pattern in the classification errors and download the appropriate Wikipedia articles to cover the subjects in the videos that were mistakenly classified. Consequently, when choosing the Wikipedia articles, not only the covering of the topics was taken into consideration, but also the quantity of the articles about the subject was an important factor. In response to this, additional to the initial small dataset used in the previous work, we obtained two new datasets, a medium dataset with a total of 6,373 articles, and a large dataset with 18,526 Wikipedia articles. The transcript keywords represent the key point for the classification algorithm, as the quality of the classification may be directly influenced by the relevance and quality of the keywords. In the initial work presented previously, the used keywords for every transcript were the ones found in the metadata of the video. In other words, the keywords provided by the video's author. After manually checking these keywords, we noticed that they were not suggestive for our classification in three clusters. A second solution was represented by the RakeNLTK tool, as it supports the Spanish language and it provides good results for this language too. RakeNLTK tool is a domain-independent keyword extraction algorithm which tries to determine key phrases in the body of text by analyzing the frequency of word appearances and its co-occurrence with other words in the text. The limitation of the second method consists from the fact that the keywords provided by RakeNLTK from transcripts were large and numerous phrases with a focus on the essential subject of the video. This also caused classification errors in some cases. So, a third solution was needed. There were used Wikipedia articles and keywords extracted with RakeNLTK as training and testing data set for the LDA model to extract domain-specific keywords from the transcripts. The third solution is combining the RakeNLTK tool with the LDA model. RakeNLTK tool will be used to extract keywords from the Wikipedia articles, resulting in a labeled dataset that will serve later as training and testing dataset for the LDA model to extract domain-specific keywords from the transcripts. Trying to detail the third method, the following steps were followed for obtaining the domain-specific transcript tag recommendation algorithm using LDA. First challenge consisted in creating a balanced and large dataset of Wikipedia articles in Spanish. By saying to have a balanced dataset, there are supposed to be enough biology and science articles to obtain a set of keywords for biology and sciences, enough engineering articles to get a set of keywords for this domain, and most important, enough humanities and arts articles to form a set of tags for this domain too. The difficult part was to get a good set of keywords for humanities and arts domain, as this cluster covers a wide range of fields like economy, law, arts, architecture, language learning, politics, social sciences, and philosophy, and many others. The second step was to clean the text from the downloaded Wikipedia articles by lowering characters, removing undesirable marks and stop words, and using the singular form of the word. After that, we appended each Wikipedia article tags using RakeNLTK tool and also cleaned these tags. For better results, there are also tags extracted from the titles of the Wikipedia articles. That means that we pulled tags for 18,526 multiplied by 2 items. After obtaining a big set of tags, all these tags were added in a set in order to have unique appearances of the extracted tags. Then, for each of these tags, count how many Wikipedia articles were assigned to the respective tag. Then, these top 5,000 most occurred tags. Why? Because by having less tags, it means that only the most occurred tags from each domain will be kept, and in this way, classification with the semi-supervised method will be simpler to perform. After filtering the most occurred tags, keep only the articles that are still labeled. We end up with 21,743 labeled items out of 37,092 items. Now we have a dataset, so we can create the TF-IDF matrices and split the obtained dataset in 80-20 percentages. After the described steps, it is proceeded to training various LDA models using sklearn implementation by assigning each of the models different number of topics. Then the different models are evaluated on the test set using the metric perplexity. By definition, the lower the perplexity, the better the model. Now that we have designed the workflow, we focus on the keywords recommendation algorithm for the transcripts, which is based on two main aspects. The first one is the score, the topic's probability of generating the word, and secondly, a word is considered as a relevant tag when its score is superior to a defined threshold. So we chose a threshold equal to 0.008, as more than 95% of transcripts are assigned tags with this threshold. Looking at the experimental results, we can say that the experimental result consisted of analyzing the classification in three clusters by trying to classify the videos in the three clusters specified: biology and sciences, engineering, and humanities and arts. How did we How did we do this? Using three different size datasets, the small one, medium one, and large dataset for training, and three different methods for assigning keywords to each transcript. Which are these ones? So, the manually provided keywords by authors, the keywords extracted with the RecNLTK tool, and finally using the term method of providing more domain-specific keywords for every transcript. The one we described before, as we used LTA as business logic for the implementation of transcript keywords recommendation system, and used the RecNLTK tool for providing keywords for Wikipedia articles. As an answer to the title of this paperwork, the best results were obtained by training the semi-supervised method with a small dataset of Wikipedia articles, and the keywords provided employing RecNLTK for obtaining training and testing data and LTA to obtain the proper transcript step. So, providing an answer to the title of this paperwork, these results were obtained by training the semi-supervised method with a small dataset of Wikipedia articles and the keywords provided by using the mixed method with LDA and RecNLTK tool for training. The results are presented in this table that provides a detailed insight of the semi-supervised training process results, along with the number of transcripts added to the model in every iteration and with the classification accuracy obtained for each label. The computation of the classification accuracy matrix is done on the validation dataset, which contains only unseen data in the training step. This table presents the comparison between all 9 experiments, the 3 datasets, and the 3 methods of extracting keywords. Analysis of the interactive semi-supervised training process in all 9 scenarios revealed several patterns. The first observation regards the fact that the number of iterations has low variance. So, they can be said that irrespective of the size of Wikipedia dataset and the method for obtaining the keywords, the number of iterations is in the range from 6 to 12. This observation represents a clear indication that the size of the training dataset of Wikipedia article does not highly influence the semi-supervised learning. Another observation is that each step in the semi-supervised training keeps unchanged or slightly decreases the F1 score while slightly increasing the accuracy of the tenfold cross-validation on the Wikipedia test dataset. This observation shows that all experiments are consistent and produce similar behavioral patterns in terms of accuracy, precision, recall, and F1 scores measures evolution in terms of evolution during semi-supervised training. Okay, so as short conclusions for this paper presentation, there can be stated that this paper presented a method of classifying video transcripts using a small dataset with self-provided keywords for transcripts. When RecNLTK to label Wikipedia articles that will train a LDA model that will assign relevant tags to video transcripts. It was a great aspect to work with a real context, a real environment. The video lectures were from the sharing website of the Universidad Politécnica de Valencia, which has more than 55,000 short videos, mainly in Spanish. And, as a future perspective, the obtained classifier may be further used for labeling new videos that may be added into UPV Media site and be helpful for the students. This is the end of the presentation. Thank you so much for your